This is a video description for comparing software versions, different software and their versions. One prime example is your Windows operating system, or maybe if you're on Mac OS, they have different versions. So these software versioning, they're usually in the form of major, minor versions separated by dot. So you can have Microsoft operating system, some sort of OS with 12.1 or 12.1.0. So what does that mean? Usually the very first one is the major release. Usually you can have minor version that gets released maybe every year, maybe every 6 months. Sometimes they have minor revisions. These revisions are not major features that you would expect, but sometimes these revisions encompasses bug fixes. So you're given these software versions. Your job is to write a compare versions check at runtime. So assuming this is a web service or maybe some sort of validation code will be called upon every time a user is trying to compare the two versions. One example is this: you can have a runtime service that gets called every time a user launches the software, assuming the user has internet connectivities. The software sends the version number to the central repository, which runs that user's version against the stock version that is current. This function basically returns a integer stating if version 1 is greater than version 2, returns -1. If version 1 is less than version 2, returns 1. Otherwise, return 0. If both version 1 and 2 are the same, return 0. 1 is the same as 1.0 because the minor version 0 doesn't really matter. This 1 is equal to 1.0.0. You can have 1.0 being the same as 1.1.0.0. This versioning can go on and on and on, right? It's not just the major, minor revision. After that, it could be bug fixes, update numbers, and rectification numbers and stuff like that. And it will just keep going. Your function should support any number of trailing dots. We're using these dots, DOT, as a delimiter or separators. They are not spaces. You can't have one space 0. It should be 1.0. Let's look at a couple of examples. Versions are coming in as strings. What you have is a string 1.0, not a double 1.0. That's different. So it's a string. When you're doing a string to string comparisons, this is what we call lexicographical comparisons. And there is a natural string orders. Comparing string to string follows a specific rule set. You can't just do ver1 greater than ver2. If ver1 and ver2 are both C++ string, this is going to give you incorrect results. So how do you compare these things? You got to do apple-to-apple comparisons. This one has dot in it, so you can't just compare the entirety of payload against each other. But let's say if you have 1.1.0 against 2.1, parse each of these number out. String manipulation part of this problem comes into play. You have to iterate through the entire version 1, basically just pull these numbers out, parsing. So you have a version 1, a major minor revision, and you have version 2's major minors, and there's no revisions. If there's no revision, it's assumed to be 0. So you're comparing major against major and a minor against minor, right? And obviously, if major do not compare, then you can exit because you got your results. If major matches, then you compare the minors from, right? You got to do apple-to-apple comparisons. This is the approach to get this to work. The bulk of the logic is parsing your version 1 or version 2 and tokenize or getting out of these major out so they can do comparisons there, getting all of the minors on both sides out, version 1 and version 2, do comparisons that way. The safest thing to do is when you pull them out, this is a chart. So you got to convert it into an integer. It's much easier to do an integer comparisons that way. There's a couple of hops that you have to do. The chart itself is an integral value, so you can compare that against this. When you do a version 1 to version 2 direct comparisons, especially with dot in it, version 1 could actually be less than version 2, even though on the outside it looks the opposite. Do not use string to string comparison. You can also use S2I, a C++ string comparison. Assuming string is S dot S2I gives you the ability to convert string character into a digit. Be super careful with the comparisons part. You can also have multi-digit version numbers like 256, right? So this will come in as 256. You can actually use S2I to convert it into a digit. Be careful of situations such as when you have zero point 0.0. This is the same as 0. Or you can have 0.0 against point 0, point 0, point 0, point 0. They're actually the same. And most of the use cases would be 3 digits. You have major minor revisions. Sometimes there will be long cases like this. This long case requires you to generalize your problem to go past major minor revision. You might be able to get most of your test cases out working in a standard major minor revisions use cases. This is not a super straightforward, easy problem, but with time and some thought, think through and beyond generalizing the problem, you should be able to solve it with no problem. So this is your starter code. Make sure that you copy and paste this as your starting point. Do not use CIN anymore. You don't need to ask users to enter these things. In your main, this is your test code. This is just an example. Your target function will be tested as such. There's an example of this that you can write. Let me know if you have other questions. Good luck with this one.